and switching over to Håkan.
Yeah. Now we heard the sunset is happening. There's no possibility anymore to postpone it. You can't argue for that. Well, they won't. Right. There's too much money in it. They won't. They're doing it. And we have been talking to our customers for quite some time that LTE have to be in your devices. And right now, when you buy an LTE modem, it's always, I would say, always fall back to 3G and 2G. And that's happening. And those chipsets have been developed for quite some time. If you look on most of these modules have Qualcomm inside. There are some Chinese chipset vendors as well, of course. But those chipsets have been designed for quite some time ago, and they will continue to live for as long as they can be manufactured. And then they're gone. And I think that should be taken into consideration. So down the history lane, I think that many of us, not all of us here, but many of us here have been there for quite some time. I actually remember 1G. It wasn't called 1G then, but you realized it well. Yeah. 3G, this is where I started my journey at Ericsson Mobile Communication. That further changed to Sony Ericsson Mobile Communication. I was part of the first M2M products. This is machine to machine. We made some PC cards, when you slide it into a computer and there you go, you had mobile broadband with 56K something. But we did that. And as you said, it's hard to find the real business case or the use case for the different technologies as you're there, because it was fantastic just to be able to connect wirelessly. And then it was perfectly fine to connect a little bit faster, but there was this intermediate thing called Edge, 2.5G. This was hype. And then when you started to look on the bit rates, and imagine where we are now, that most of the IoT installations are transferring small chunks of data, a sensor value, some configuration data. You might be able to reconfigure a device remotely, but it's small pieces of data. And I would say that that is a history that comes from the fact that we had less than hundreds kilobits per second. You didn't have anything more. But when we have 4G, we can now have more than 150 megabit per second in download, depending on which category you decide on 4G. You can do so much more, and just look on your handsets. You can stream video, you can stream a lot of data, and AI coming strongly. And just imagine that you have been storing data in some cloud, which you didn't because it wasn't a cloud by then, and you didn't have a lot of storage. And by the way, you didn't have a lot of bandwidth, so you didn't store. But let's imagine that you had stored data over here. That would be gold for this AI training, and new business opportunities would arise then. But okay, now we have this bandwidth. So what are we doing with the IoT? And IoT is not the small sensor only. We can categorize this in different ways, but this is one way of doing it. We have IoT sensors, IoT gateways, a little bit higher data rates. And then we have IoT routers. And this is where you have maybe a cellular modem being a gateway to multiple Ethernet ports or optical fiber or what have you. And this is still an IoT device, depending on what it's used for. So starting on IoT sensor is totally okay with maybe a kilobit per second or 10 kilobit per second. It's totally fine. Some moisture data once a day. But if you go up to the IoT gateways, this is maybe where you need up to 150 megabit per second-ish in downlink, and 50 megabit per second uplink. That could be sufficient. Again, it's nothing preventing you to store a lot of data, to upload a lot of data to the backend. Now you can start processing a lot of stuff. And this would be something else. I won't dwell on that so much more. For this lower region where you talk about sub 100 kilobit per second, there is this standard, the LP1 or cellular LP1, where Cat narrowband or Cat M, which is slightly higher data rates, this is where they reside. These are extremely cost efficient. They are low power. They're not used that much yet. When it comes to IoT, narrowband IoT, they have some drawbacks. On the other hand, you could argue for when you put electricity meters and water meters with narrowband IoT, you get huge volumes based on that. And I know that there's a huge rollout of that. Cat M, we say also that narrowband IoT is not really LTE. You took away a lot of the infrastructure in the modem. So you took away parts of the radio, parts of the baseband. A lot of features of LTE is not there yet. So you don't have voice capabilities in narrowband. You don't have handover capabilities so that you can be moving in your car and do continuous handover between base stations. Those features are not there. So this is mainly for fixed installations, the electricity meter. Cat M is a slightly reduced capability LTE modem. You removed some parts. You still have voice capabilities if you want to. You can do handover support. So you could potentially use Cat M in a very low bitrate phone, theoretically. And we're talking about, for the Cat M2, we have 5 megabit or 7 megabit, depends on. And what I said here is that the first number is the downlink data. So if you downlink data, you get 5 megabit per second, and you upload data in 7 megabit per second. And then when you go a little bit higher, we have Cat 1 and Cat 1 bis. These are interesting standards, where Cat 1 bis is a very new technology, I would say. It's driven by all the wearables, a watch, where you can't have multiple antennas inside. Most of these LTE modems, so I would say all of the LTE modems would require dual antennas, where one antenna is used for reception diversity. The BIS, the Cat 1 BIS, is then enabling using only one antenna. And since it's intended for that use, you can actually remove half the receiver infrastructure in the modem. You can remove the antenna, of course, the PA amplifier. And there's a lot of infrastructure and some software as well. So these are really cost effective compared to LTE Cat 1. They're still the same bit rate. So you can get approximately 10 megabits per second in uplink and 5 in downlink. You can use single antenna only on BIS, but you do need 2 antennas on Cat 1. Especially in US, American operators are very specific on that. We require dual antennas, antenna diversity on the devices.
May I just add one thing about the BIS that I think is worthwhile recognizing? It's the receiving antenna diversity that's being removed. Yes. Uplink is always only one antenna. And I mean, surely it's always good if you have good reception, also downlink, but most IoT devices are actually transmitting data up to the cloud. Surely could be both. But from that perspective, this version is not a bad idea, actually.
No. And I will come to some pricing later, because that's kind of impressive when you see the cost efficiency of Cat 1 BIS. So,
and just understanding, this is all lit in the networks available now. Support for Cat 1 and Cat 1 BIS.
Yes, on most markets. Then, as Håkan points out, some operators, not many, but some are reluctant to the BIS because it doesn't have 2 antennas. They have just decided that it should have 2 antennas. And then the device certification process with some of the US-based operators typically could be difficult. But I think that's a matter of time.
That what you would see when we talk about chipset manufacturers is also that a lot of markets, specifically US, but there are other markets as well, that are very reluctant of using Chinese chipsets in the modules, while Qualcomm being really the biggest chipset manufacturers, American operators would accept a Cat 1 BIS module based on Qualcomm, but they would reject a Cat1bis module using some Chinese chipset vendors. And this is fact that we got from one of the bigger module manufacturers. They still think that this is changing, but it's changing slowly. Okay, so does it make sense? You see the bit rates, and of course I focus now on the lower bit rates. When we talk about IoT so far, we've talked about small pieces of data and low data rates. 5G would take you up to 10, 20 gigabit per second. And I'm sure that we will see IoT systems that will make use of that. I'm quite sure. But so far, when you talk about cost efficient, power efficient, not the least, because the GPRS and 3G are power hungry. Just imagine when we started, I've been there, trying to design battery operated GPRS stuff is a headache. And when you do battery operated LTE stuff, is really simple from a power management point of view, and you can get really good battery longevity using LTE. So this is where also you can transform from fixed stuff having to be powered from the mains on GPRS, and now IoT devices will become mobile with battery operation. So cybersecurity, this is one of my favorite topics. I love this. It's a mess for a lot of companies out there, and I realize that if you are making generic IoT gateways and sell those to customers, this is a headache, because in 2025, summer-ish, it should have been 2024, the red, when you're type approval stuff in Europe, you need to pass a red directive. And they will have a mandatory set of requirements for cybersecurity. And if you read those through, we have interpreted these requirements and we have I would say, fairly good understanding, even though the standard is not ratified yet. So the most realistic set of requirements that will go into the red have been reviewed by us. And the interpretation is that if you do OTA updates, which you have to, by the way, because it's really hard to sell a device that you don't update because of cybersecurity. So it's almost, I would say, mandatory. Depending on if it's a small device with a sensor that only sends temperature data once in a while, I think you can get away with that without having to support software update. But if you have more than that, if there is a Linux system, a Linux gateway or a sensor with more complex features, you actually have to. And this comes down to the fact that there are so many people out there hacking Linux and identify security holes in those. And then there are security patches coming continuously from Linux.org, and there are so many different bulletins out there where they present all these found issues. And as a vendor, you need to have someone in your organization. This is mandated by the Red Cybersecurity, by the way. You need to have a process where you study enough bulletins, security bulletins, to judge whether this security issue is an issue for your devices and for your customers. And if you decide that this could potentially harm our customers or our products, you need to have another process, a process in place to inform the users that we have now been notified that there is a security issue and we're working on a solution, and within a timely manner, which is like a subjective thing, in a timely manner, we will come with a software update and we will keep you secure. And then you need to update this firmware. You need to do the updates and roll out this on all your devices and make sure that, of course, that there is no problems involved in that software rollout. That's one thing. The other thing is that you need to make sure that all communication is encrypted. And you could argue for that, yeah, but there is encryption in LTE or 5G, so you have already some kind of encryption. But you might want to do end-to-end encryption. And that might be a typical solution if you have TLS encryption or mutual TLS. In both these cases, where we talk about OTA updates and the encryption of data, the amount of data that you send increase. Especially this one, because you might have a Linux gateway and you need to update tenths or 50 or even more megabyte of data in each IoT device out there. And now you made a business with Telenor Connexion that we have a data pool of X number of gigabyte per year that can be spent by your devices. And now you're forced to do an OTA update. And the whole data pool is consumed by a one or maybe two OTA updates. So this is a cost thing. And this is where you need to discuss with Telenor Connexion, for example, that, okay, so how do you handle this? How many OTA updates do we predict that we should do? What is your headroom for issues that you are totally uncontrolled of? Someone is hacking devices and finding issues, and you need to react, and that will cost you. And the other thing, the encryption of data adds, it's not much. Data encryption doesn't add that much, but it's still something. You need to exchange data back and forth. And if you have hundreds of thousands of units out there, that adds this a little bit more data. It's the same thing again. Consume data out of your data pool.
And your battery.
And your battery. Battery.
And back to your point on narrowband, which usually is not a great choice for OTA updates. Actually, I've always been kind of pro LTM, usually. I mean, there are definitely space for narrowband as well, but LTM has so many advantages and not that many disadvantages, actually. Sure, the model was a little bit more expensive maybe, but then you probably get 2G fallback as well, which still might be good on some markets for a few years. But no, I think that the OTA update is something that you should consider also in your design choice.
Yeah, this is maybe the biggest problem. And I started to talk about the hurdle of all the companies that make generic IoT gateways out there. There is one more thing that comes with cybersecurity, and that is a secure boot. You need to make sure that only your software can run on that device. And typically that means that you have secure boot. Your software needs to be signed by you. So if you sell a device, you do the software update, addressing some issues, and then you sign that with your private key. And then you send that to the device, and the device already in manufacturing received a few hashes of your key. So now you can have different signatures. Depending on the chips that you use, you can have 2 to 3 different signatures supported in them. And you send your software that is signed by you to the gateway, and it will update, and it will boot from the new device. It will verify that it's your software, and there you go. But what if this generic gateway is signed, have these three certificates or the keys in memory that comes from that vendor X, and you will update your software. Then you need to send your software to vendor X, and they need to sign that software with their certificate so that you can run on the device. And imagine that vendor sells millions of gateways to a lot of different customers. It becomes merely impossible for them to handle this structure. So they need to find another way of doing things, and I'm sure that there is a lot of ideas out there how this should be done. But this is an issue.
If you have have shared keys in each device and the private key, you could reverse it so that each device has unique keys. But then your vendor would have to support flashing them with your key. A unique key or unique keys for each device. But it's doable.
That would be doable. But then it's maybe even more complex for them to handle multiple, because those keys are typically burned in production or last stage flashing or something.
Yeah, they would have to deliver each unit with the keys to you in a secure way. But then if they leak, it would only be for one device. So.
Yeah. So, good point. Cybersecurity is really important. RedCap. So you remember the slide that Martin showed you, that is the enhanced mobile broadband. You have heard about this. This is like 3 cornerstones of 5G. you have this huge, massive machine-type communication. Massive IoT was an earlier name of this. And then ultra-reliable, low-latency communication. This is where everyone seemed to think that self-driving cars will use 5G. and this is not really true. We can have that discussion separately. But there is this thing in the middle, the red cap. Red cap stands for reduced capacity. 5G reduced capacity. This is where I try to... So honestly, 5G modems are extremely complex and expensive. And today, all the 5G modems that I know of require at least 5 antennas for the chipset that you use in a device. And then on the base station side, it's even worse. Then you have massive amount of antennas, right? But if you have a device with 4 antennas, it's complex to design, so it takes a lot of effort, and the regulatory aspects are a hurdle. But if you can reduce the complexity of this 5G modem and make it running on 1 or 2 antennas, try to address some space that are now consumed by LTE, then this would be some suitable 5G technology to use for IoT. But I'll show you in the next slide that from a cost perspective, this is not where we're yet. A 5G modem can cost you actually $150, $160 for a not very specific complex, well, they are complex, but not a... It's a modem that you should use for your device, for IoT or a mobile phone or what have you. You can use that for anything that should be 5G connected. It's not the Rolls-Royce kind of module. It's one of the standard modules, $150, $160. RedCap, you mentioned it slightly. The core network, you can't really use the RedCap unless you have a standalone 5G network. And with standalone means that you're not using the LTE or 4G core network anymore with 5G base stations, but you actually use a 5G core network as well, adding more features and higher bandwidth. So, and this is not rolled out to that massive market yet. This is happening. I can't tell you anything about the progressiveness, but it's happening. But so you can't go and yeah, please.
Yeah, I mean, typically you'll find it in the US, you'll find it in Singapore, Malaysia, places like that, China. So I mean, some markets they have been forward-leaning here, and private networks definitely could be there.
Yeah.
But looking around Europe, you won't find it in many places yet. But it's being rolled out as we speak. And there's going to be quite some investments made, I can assure you.
Daniel brought up something very interesting, and we are discussing with a lot of different customers regarding private networks. And private network is where typically, you can take Tesla as an example. Tesla build their huge automobile factories. They can be their own operators, private network, in their equipment. In their facilities, they can make multiple base stations so that they have their own frequency range, frequency bands to use freely. And their devices will not cost a lot of subscription data. Like they can now connect tools and machines and everything. And this is where IoT, because that's for sure IoT. This is where IoT will make use of really high bit rates. Remember the prior slide when I talked about 20 gigabit per second in 5G. Well, it will happen, and for sure it is happening when you talk about private networks. I mentioned that it's reduced complexity, and one of the things that they reduce to get this lower cost and slightly better power consumption, etc., is that it's half duplex. And if you can live with half duplex, that's fine. And it's single antenna. It enables single antenna. It supports dual antennas, antenna diversity, but it do support single antenna. So if we know that we're leaving 2G and 3G, how can we understand what technology to use? So I mentioned CAT-M, CAT-NB IoT, CAT-1 BIS, and then there was this CAT-4. And then there's a huge number of CATs out there. Good, huge data rates. And then you have 5G RedCap. And then you have 5G, the massive bitrate. So how do you know where to go? And this is one simple tool that I made this up myself. So of course there are other ways of looking on it, but I think that this could be a tool for you to use. So first of all, would you have to communicate over a longer range? So this could be, longer range doesn't necessarily mean kilometers. It could mean down in the basement, in the concrete building with a lot of steel material and stuff. So if you do that, would you require larger data? Or is it really a small number of kilobits per second that you require? So if it's small data, you can use this narrowband, it's a Cat and narrowband IoT. We're talking about up to a few hundred kilobits per second maximum. It has the disadvantage that the operator, this consumes actually spare performance in the base stations. So when you start using this for massive OTA updates, if you have like a few hundred megabytes of data, it's a Linux system, and you're updating the Linux system continuously, this would ruin the bandwidth of the base stations, and the operators would not like this. So this is actually something that we talk about quite a lot, that if you are doing OTA updates and it's massive amount of data, don't use narrowband IT. Then Cat-M is better, and you have a few megabits per second support. It takes a little time to do the OTA update. This would take a huge time, but it takes less time. But it's still, both of these technologies would give you a longer range because their technology, these are made for, and I think that when we talk about Cat-M, I think we have in the range of 20 dB longer operating range. If you talk about I don't want to express this as kilometers because there are so many factors involved, like if you're going through concrete or stone or if there are woods between. But 20 dB more dynamical range is really, really essential. When you consider the other opportunity, we don't need to have longer range. So you can decide to use not low LPWAN. Do you need a small device? Small device in this case could mean wearables, this watch. That could then be translated into a single antenna. So do you need a single antenna? And then the next question would be, do you need more than 2 megabits per second? If that's a no, you can use the Cat-M with a single antenna. It supports 1 to 2 megabits per second, slightly more maybe on the latest releases. But if you need more data, then you should move over to, should it be more than 10 megabits per second? Or is below 10 megabits per second sufficient? And if it's not more than 10 megabits per second, you can use Cat1 bis. Single antenna, really cost efficient. But if you need more than that, you should go to RedCap, or because this is really where you get 150-ish megabit per second in downlink and 50 megabit per second in uplink, which is the same as Cat4, LT Cat4, by the way. You don't need a small device. Then again, do you need more than 2 megabits per second? No, we use Cat-M again. If you need more than that, you have the Cat1 for the lower bit rates and Cat4 and RedCap for the dual antenna. And the reason for not showing both LT Cat4 and 5G RedCap over here, because this was, remember, a small device defined by a single antenna implementation. And LT Cat4 requires 2 antennas. So by using this kind of decision tree, we can simplify the selection of different technologies. And again, there are more parameters here. You can bring in parameters like power consumption. And then there are the Cat1 bis, for example, is power efficient, and the Cat-M and narrowband, these are actually made for smaller devices. But then the thing that might, in the end, make you decide one or the other technology is the pricing. And we are agnostic to different module vendors and chipset manufacturers. We work with all of them. But this morning I received information from Quectel. So these pricing are budgetary pricing, when you talk a project with Quectel, you should negotiate with them directly if your volumes are good enough. Otherwise, you go through distributors. A Cat M2 modem would cost you approximately $10, in the range of $10. If you have a Cat narrowband ID, and this is important, when narrowband was introduced, everyone said that this is where cellular modems comes down to $5. And then no chipset manufacturer released a narrowband single mode modem only. They always combine narrowband and Cat M because there were different markets. US and Europe were going for different technologies to start with. Everyone understood that we are going probably to integrate both systems on all markets, but we started in different technologies. So Quectel, for example, they introduced modules that were both of these, and this is actually a $10 supporting both. This is a $6 module that is specifically for an NB because they have released it. When you talk about Cat 1 bis, we see $10 to $17-ish because, well, so the difference is China chipset or Qualcomm chipset. And again, if you're releasing this on the American market, you might have to go with Qualcomm chipset. So $10 to $17-ish for the Cat 1 bis. And when you talk about the red cap, we're up to $70. And this will, of course, be reduced over time. This is a new technology. It's being launched or rolled out very much now. But $70 and the performance that you get from this is very much the same as Cat 4, which we would find here, that costs you $30. So if you have you need 50 megabit per second in uplink and 150 megabit per second in downlink, and you have the space for two antennas, LTE Cat 4 is a better option, at least for now. And then the thing that we see for many customers, Cat 1 and Cat 4 would be maybe the most common technology to implement in IoT devices, especially if you do IoT gateways, which we do a lot for different customers. Cat 1 and Cat 4 are the most common. I would say Cat 4 is the most common. Any reflections, especially to the pricing? Would this tool be kind of useful for you when you're looking for next technology on where to go? Do you think it makes sense? Because I think I realize that it's hard to, and you hear these things at Cat 1 and Cat 1 bis and Cat 4 and Cat M, and I understand it's hard. And you leave something where you had GPRS. And one more thing, everything which is blue here, everything which is LTE will more or less quite surely have rolled back to 3G and 4G. So if you don't have LTE coverage, it will go back to 3G or 2G. But when you go up to 5G, they will only be fallback to 4G. I can't really see any chipset vendor that will support LTE. Have you seen any? No.
No.
The chipset vendors, they know that there's a sunset going on. So why should them? It's a cost thing as well.
Yeah, there's very little fallback of 3G. It's mostly 2G.
Yes, you're right. You're right. Any other questions or reflections?
Maybe you said that, but the 5G modems have 4G fallback often.
Yes. Yeah. So that's important. So and as you said, 4G and 5G go hand in hand. They will coexist for a long time. I don't foresee that we'll have 5G only modules.